So how's everybody doing this morning?
Doing okay. I did a lot of studying yesterday up until my brain was like, well, we applaud your efforts. That was really nice, but you are now finished and anything you continue will, be useless.
Yep.
So time to switch subjects.
The brain gets to that point. Absolutely.
I think a lot of it, I have a feeling that I feel behind in 3.5. And so, and not necessarily behind, but their concepts just take a lot more review and to understand and to get. So I'm spending less time on everything up to 3.5, and that makes me a little nervous. Whereas I'm trying to weigh out the weight of it.
Yeah.
Do I spend time on something that I'm less, or do I make sure I'm really strong at things that I'm, the rest of the test? So
I would tend to go towards that rest of the test.
Okay.
3.5 is certainly there. I think one of the reasons 3.5 tends to bother people is because there's really very little to no mechanics in it. You're really not meant to be taking it and, plugging things in and calculating stuff. It's really just observe what's happening.
Yeah.
So, for example, if that's our function, f of x, usually in the section we're told things like, okay, a new function that we're going to call g of x just to give it a name. That new function is, say, 2 times f of x minus 4 plus 3. There's nothing for us to mechanically, well, not much anyway, for us to mechanically do to this. We're not plugging this into anything because we don't have a function to plug it into.
Yeah.
Even if we did, we really, in this section, shouldn't be plugging stuff into it. We're just observing what these things are going to do. And we know this, or the idea of the section is to understand what this minus 4 does, that minus 4 is going to push the function in the positive direction 4 units. This plus 3 is going to push the function up 3 units. This 2, because it's on the outside, is going to stretch it to twice its height. The thing about the stretching is it is twice the values here. So numbers that are, or points that are near the x-axis, when we double them, they don't move very much.
Yeah.
But the points up here, when we double those, they stretch, up quite a bit. So the stretch is the stretches and compressions are the ones that do a kind of a full deformation of the function, actually make it shape different. So if we tried to perform these movements on this function, the minus 4, again, it's going to move us 1, 2, 3, 4 that way. That's what it does to the graph.
Yeah.
The stretching by 2, well, it's going to grab this thing, see if I can make this work, and stretch the top part up by 2, the bottom part up by 2. So roughly, it's going to be stretched out. And then this lift by 3 is going to take the function and go 1, 2, 3. And that's where it's going to end up.
Now, for chapters in the future, is this all going to be 3.5 stuff progressed?
Not really.
Okay.
There are 2 goals really for this section. One of those goals is to be able to, if we're given a function like, say, 3 times the square root of 2x minus 4 plus 5, and we need to it's helpful to kind of intuitively know where this function is happening.
Okay.
Just being able to, that that's terrible. That's why I don't do that. Being able to look at this and go, okay, I know what the basic function looks like, what the square root looks like. What does the structure here tell me about how this is going to behave? Well, I know it's going to move that way 4, it's going to move that way 5, it's going to be compressed to half its size, and it's going to stretch that way by 3. So I go, okay, over, up, compressed, stretched. We can have a sense of, well, particularly things like where this point's going to end up. You know, that point's going to go over 4. Oh, that's going to bug me. Too much. That point's going to go over 4, then be compressed halfway to 2. Stretch by 3 isn't going to move that point because it's at a 0. Then up 5. So this point is going to end up there at 2, 5. And everything else, it's going to be squishier this way from the compression by half. So it's going to seem steeper. And then the multiplying by 3 is going to make it seem a lot steeper. So this thing is going to look like that.
Okay.
So being able to kind of go, okay, I know how this is behaving. I know how these are affecting the behavior of a basic function that I know is one of the big goals in 3.5.
And what's the other goal in 3.5?
The other goal for 3.5 is preparing us for Math 112 for trig.
Nobody wants to do trig, Matt. Come on.
Everybody's going to do trig. Shut up. Because the functions in trig are waves or types of waves. So the way we graph waves is to take those waves and go, okay, ooh, that's 2 sections, that's okay. Take those waves and go, okay, we're moving those waves, we're raising those waves up, we're taking those waves and compressing them, we're stretching out their amplitude. So this idea of taking a wave of this shape, saying, hey, this wave can be any wave that we want.
Yeah.
By taking that wave, taking the function for that wave, and saying, okay, increase its amplitude, shorten its period, perform a phase shift to make it start somewhere else, and then lift it into the values I want. Those transformations on the wave is going to build that wave into whatever wave we're trying to model. So that's the other thing it's trying to get us prepared for.
I'm actually thinking about taking trig. Are you teaching trig over the summer?
I'm not teaching anything over the summer right now.
Well, then I'm not taking trig over the summer.
But trig is awesome.
Yeah, but I don't want to take a math class without you. So.
Well, that's limiting for you.
That depends on the math teacher, is how limiting it is.
So one of the big things, is to take functions that we know in this section. Take functions that we know. Say we know what 2 to the x looks like. It's an exponential function. So 2 to the x generally looks like that, right?
Mm-hmm.
And say things like, okay, what's going to happen if we look at 2 to the x minus 4, or 2 to the x plus 5, or 2 to the x, say 2 to the 4x.
Negative 2 to the x.
Ooh, negative 2 to the x. Negative 2 to the x. That's a good one. Or 2 to the negative x.
Mm-hmm.
What is that negative, that 4, that plus 5, that 4? What are all those going to do to this image? What are they going to do to the graph? I don't want to be plugging anything in to do that. I want to know what these transformations do. So what's this minus 4 going to do to this image? Crystal.
Oh, dang it. Now, hold on. I'm getting them confused because one of them flips it, one of them moves over, So that would move it over
Mm-hmm.
4 to the right.
Mhm.
And the 2x plus 5, that'll move it up 5. The 4x does that. The 4x makes them twice or 4 times as big.
4 times as fast.
It's fat. What do you mean by fast?
It's so this grows fairly fast, right?
Yeah.
So
This
Oh,
one's going to grow at 4 times that speed.
okay.
So it's going to be compressed. So it's going to be
Oh, got it.
it's going to
Okay.
be squished that way.
Okay.
What does that
And
negative do?
flips it over the y-axis, and the negative x flips it over the x-axis. Or did I get that wrong?
Backwards.
Backwards. Okay.
And it's actually very. You might have been thinking the right thing. Might just be how you said it. This negative, it's on the outside, so it does affect our y values. It makes
Okay.
our y values go from positive to negative or negative to positive.
No, I said it backwards. So yeah, it would go down.
So yeah, it's flipping us, but the center of that flip, it is a vertical, a y flip, but it's flipping about that x-axis. So,
Okay.
but that might have been what you were thinking.
Nope. I was thinking
Yep. Okay.
from right to left, whereas the 2 negative x flips it now right to left.
So that's really what we want out of this section, not only just for us for now, but even as you get to using it in 112, is seeing these individuals and going, okay, I know what these individual things do. As you use this more and more often, and somebody walks up and says, oh, okay, I've got, say, -3 to the 2x plus 1 minus 4, you go, oh, okay, it's going to go that way. It's going to be shifted a little bit this way. It's going to be compressed. It's going to be down. So, okay, the function's going to land somewhere like that. Its asymptote's going to be down there at -4. That's more or less the behavior we have. Let's go on.
Okay.
It just takes a while to get good at thinking about all of it at the same time.
It does, yeah, because
But
sometimes my brain goes, yep, bye.
yeah, and don't necessarily push yourself that far right now.
Okay.
Right now, as long as we kind of have a sense of how the individual ones are behaving, you'll be putting more of it together in 112 and in other subsequent courses.
Yeah, I think my only option is take 112 because I don't need 112, but I was kind of morbidly curious to take it.
It's a fun class.
It was in the summer because then after that I have a year of chemistry and a year of physics. So
Oh, if you're taking physics, take 112 first. It's really helpful.
is it?
Oh, yeah.
I'll see where I can put it in. What about taking like a chemistry class and 112 together in another class?
Oh, she should be fine. I have people who take calc, chemistry, and physics all at the same time. They usually die.
Yeah, but see, that's where I'm at too. Maybe
Well,
I'll
don't
just
do that.
audit it because I don't actually need it, but it would be good information to have, but less stress.
And I think Annie does one over the summer, and Annie's great.
Okay. Wait, which one's Annie?
Annie Grillard?
Is she the Asian woman that subs for you?
No.
Okay.
And he's great. I took 65 with her, and it was pretty awesome.
Yeah, Annie's awesome.
Okay. I might. We'll see.
Anything else that you guys? I mean, 3.5. I know it's weird mostly. I was unfortunate that Andrew's not here today. I know Andrew was struggling with it, but he was asking a lot yesterday about trying to look at it from the perspective of what do I plug into what and what do I solve for. And you can do it some that way, but it's really not the way it's meant to be approached. It's meant to be approached in this more kind of abstract, how's this making our domain and range move around? So it's people who are very focused on mechanics. What do I plug in? What do I solve for? Sometimes struggle a lot in 3.5, and it really has to be looked at more from a graphical perspective. And if you don't like of graphs, you're going to not like a 3-5. Oh, what else you guys got today? Anything else you're playing with, fighting with? I don't know why the scratch paper turn-in link for the quiz didn't work. I tested the one for the exam today, so that one should work. If it gives you any trouble, let me know. But I am glad we kind of tried to practice that. If a lot of you guys that noticed that when the quiz link didn't work, you just sent it to me as an email attachment. So I'll go through those, and that's a fine option if those things don't work, just to kind of say, hey, here it is in one way or another. But I did test the one for the exam. It should work. If it doesn't, let me know and send me what you can, how you can.
What about the turn-in homeworks? Because I've had trouble with those.
I think the link for this week work or not work?
I don't know. Did you get them?
I thought I did.
Okay.
I've seen a bunch of them.
Were you guys just talking about the scratch work for the quiz?
Yeah.
Yeah.
I know that one didn't work.
Yeah, I emailed mine and sent it, but I didn't know if it didn't work.
But yeah, when I hit the quiz for scratch work, it says no question and assignment. I don't know what happened to it. But if I check the one for the exam, which should be open today, there it is. It does have the upload your work file. But the hand-in homework that was yesterday. The hand-in homework yesterday did have the file, and I got a whole bunch of those. So I started going over those last night. So
I had trouble with the very last question on 3-5. Of the homework.
question 20.
Yes.
Okay. So let's look at it.
So like most of everything else in there, I understood pretty well, but I got to that one and I just there wasn't even I don't think there was a video with it either. So
yeah. So if we're going to try to write the equation for this function, there's a couple things we have to do first. One, looking at its overall shape, we have to determine what type of function it is. So is this a parabola? Is it a square root function? Is it an absolute value function? So we do have to know what some of our basic functions look like well enough to be able to determine that this is an x cubed that's been moved. So that's step one. So this is an x cubed. So we're going to start, I can't write here, but we're going to start, okay, this is an x to the third. Now it's an x to the third that's been moved around. So we're going to have to modify that, but that x to the third is our basic function. And okay, what does x to the third normally look like? Normally x to the third does this inflection. It's technically what this is called, where it kind of starts to turn around but doesn't and turns back. This inflection point usually occurs at our origin, right? So that origin has moved over 1 in the positive direction horizontally, and it's moved down 2. So inside that function, that subtracting 1 in the function, that x minus 1 is going to move that center point 1 that way. Now it's also got to go down 1, 2. So down 1, 2 means we've got to be subtracting 2 from that whole thing. Is that fair so far?
yeah, I just didn't realize that it was cubed. Everything else that you're doing, I understand.
Just starting with that basic function, yeah. And this section really does kind of rely on us knowing or being familiar with what does absolute value of x look like, what does the square root of x look like, what does 5 to the x look like, what does the natural log look like. So those knowing what those kind of fundamental functions is. And Crystal, kind of gets back to what you were saying, you know, some of the goals of this section. One of the goals of this section is to do exactly that, get us familiar with those basic functions. Now, I think this also has a vertical or horizontal compression on it, because if you look, the point on x to the third, 1 to the third is 1, so it should go through the normal function, should go through this 1, 1. So from here, it doesn't go to the point, you know, doesn't go to the point over 1, up 1. So it looks like there's some sort of vertical or horizontal compression on it. I'm going to guess it's a vertical compression. So I think it's being squished by half. That's a little bit tough, I think, for this particular, you know, trying to realize that is a little bit tough. But that might be what I would say it is. Oh, yay. So I think that 1/2 is the tough part of this question. Outside of just recognizing the function you have to use. But yeah, knowing that, go ahead.
I was to say thank you.
Oh, you're very welcome. But recognizing that this is an x squared, we're fairly familiar with parabolas, so starting that with an x squared is pretty reasonable. Notice, by the way, this is a transformation question technically, but also this is the vertex form, right? So from a transformation perspective, we would go, okay, back 3, 1, 2, 3, and up 1. So we'd put, you know, the start of our, well, should be a parabola. So we'd put the start of our parabola there and then have it go up or down. So this one would be down. Not that much necessarily. But if we instead think of this as from our vertex form perspective, well, the vertex should be -3, 1. It's the same place. It's the same logic. One of the reasons this vertex form is so good at showing us the vertex is because that transformation over 3 up 1 is very apparent in this form. So there is a nice overlap between vertex form and this 3, 5 transformations. The absolute value, because it's an absolute value, we should use the absolute value tool. Because it's an absolute value, we know the basic absolute value function is going to behave that way. So again, what are all these things going to do? They're going to push it that way by 2. Ooh, that's kind of cool. You can move the point. I didn't know that. Anyway, it's going to push the whole thing that way by 2. It's going to drop the whole thing by 4, and it's going to take this point and move it up to twice the height. So it's going to be much more steep and happening down here. And it just takes a while to get real comfortable with, oh, what do all these things do? But the nice thing is, once you do, you can get a sense of how a function behaves very, very quickly.
Yeah, the absolute value, for whatever reason, I was stuck on this question for a lot and did that over and over and over again.
And a lot of that might be that we haven't dealt, or you haven't dealt in your background with the absolute value function very often.
Yeah, or just the math, or just stupid mistakes. But
one of the things to be a little bit careful of that I mentioned in that video is clear. Yeah. Be careful, a little bit careful about the order. You do want to work kind of from the inside out. So we do want to do this -2 first. So imagine it moving to here first. So that's going to be the first thing that we want to have happen. Then do this doubling. So then I want this point to double. Then take this whole thing and move it down 4. Now I can't grab this image and move it down 4, but I can try to make another one. 1, 2, 3, 4. Will it let me? Oh yeah, it will. Awesome. So then move it down 4 before kind of getting rid of this one. So that order is fairly important. You want to do those horizontal shifts first and those vertical shifts last. If that helps.
That does. It's actually way more simpler than how the video is doing with all the math and everything of plugging in the points and then subtracting and then multiplying. And
Now, if we wanted to track a particular point here, we'd kind of have to do that. But the nice thing is, visually, thinking of this visually as well when you're doing a whole graph is nice. Now, if we wanted to track an individual point, say we wanted to track this point at 1, 1, the x value is going to increase by 2. So boom, boom. So it's going to happen at 3, 1. Then the y value is going to double from that multiplying outside. So it's going to turn into 3, 2. And then that 3, 2, the y is going to be subtracted by 4. So 1, 2, 3, 4, 3, -2. So there's lots of different ways we can kind of, depending on what information we have, lots of different ways we can kind of conceptualize it. Which always makes a section hard when there's like 4 different ways to think about it and you're trying to think about them all at the same time.
yes, exactly.
It's good because it's flexible, but it's bad because it's a lot to think about all at once. So, oh, it's a good one. So which of these graphs, let's just call them A, B, C, or D, do you think this has to be for the 3 times x
C.
equals 2 squared?
It's C because it opens up if you look at the first term, and then if you look at the +2 inside the parentheses, that would mean it would be moved to the left too.
Yep, so it's got to be that one. Bink. Yep, those 2 open down. This one is shifted by 2, but it's shifted the wrong direction. And probably the easiest wrong answer would be this one, because we want that +2 to move us in the positive direction, but we know it's going to happen in reverse. So the +2 is going to move it backwards. So yeah. Anything else you guys want to look at from any of the other sections? We spent a lot of time on 3.5, and that's okay because 3.5 can make people nervous, but anything else you guys want to look at today? I'm certainly not going to throw new material at you today. You won't listen to me if I do, because you have a test to go take.
So is the test due by 11:59 like everything else? There's a certain time on that.
It should be 11:59 unless I did something weird. Let me check. The quiz I set for the one of the other classes got set to be like 10 a.m. for some weird reason. So it is certainly worth checking. Let's see. Test. Where is it appearing? Come on. Where is it? Oh, there it is. Haha. Check my settings here. Where is it? Yes, it should be 11:59.
Will that be available after our lecture today?
Yep. Actually, since I'm right here, I'll change it over to open right now. Oh, that's not what I want. Why is this not being helpful? Ah, there it is. So now you guys can see it. And make sure it's 11:59. Just to double check. Okay. So that should be seeable and accessible right now. Anything else you guys want to look at? You guys might just be happy and want to trundle on and go take the test. Crystal, no. Okay, be unhappy and trundle off and go take the test? All right, all right.
No, I'm going to spend the day going over the review again and going over more of chapter 2 and just then take a break and do nothing, and then I'll probably take the test. I'll procrastinate.
Don't burn yourself out. You got to have that brain rest in between.
Sounds kind of like my plan.
Okay. How about you, Aaron?
I'm going to do the review, and then I want to just get the test done and over with.
Okay. Ava, Dan, James, Martin? I can't tell if you guys look happy or stressed or... It is 11:59 p.m. that it's due. Go over more on the test. Anything particular, Ava? So let's see. I gotta think of.
How many questions are on the test?
11.
Ugh.
11 p.m. tonight, yes. If it says otherwise on the online thing, let me know. But it should be, say, 11:59 p.m.
No, it's good. I'm looking at it right now.
Okay. Let's see. Do make sure that it is set to once you log in, you have to do the test all at once in one sitting and all that. So given that quadratic, one of the kind of basic questions is, well, the things we should be able to do with it, we should be able to turn it into the vertex form. We should be able to find x-intercepts, certainly y-intercepts. So why don't we start there? Take a minute and turn the standard form of this quadratic into vertex form, and then take a moment and find its its x-intercepts. And I'll give you a couple minutes to do that. You know, if it's a test, you really wouldn't want to spend more than 5 minutes or so. I'm doing that, so take a moment and do that. Oh, and I can show you a nice trick too. That'd be fun. Oh, we lost Martin. This is, by the way, a common format for this question, turning it into vertex form. You know, you've got your shortcut formulas to find a vertex, but trying to kind of like show that you can or know how to complete the square, just being able to just turn it into vertex form and have that vertex form be what your answer looks like is one of the ways to kind of show that you're comfortable doing that. So again, if you're trying to avoid knowing how to complete the square, don't avoid that. So what, 50, is that 65? So if we're asked what the vertex is, the vertex would be what, -7/2, -65/4. But do be careful. If we're just asked for vertex form or the ax minus h squared plus k form, then our answer is just that form. How do you want to go about finding x-intercepts?
Use the quadratic formula.
We could do that. And that's probably what, kind of the most natural thing for us to do, finding x-intercepts. That means let the y equal 0. So we'd be solving the x squared plus 7x minus 4 equal to 0. We do kind of want to check, make sure whether it's factorable or not. It's not factorable, so we're don't get to do that. We could complete the square on it. It's not too bad, but using the quadratic formula is perfectly reasonable. Put in the -7 plus or minus the square root of 7 squared minus 4 times 1 times the -4 all over 2 times 1. And simplify that. So we could do quadratic formula. But you can kind of hear the "but wait" in my voice, can't you? It would be perfectly fine. Nothing wrong with doing this at all. But remember that the quadratic formula is mimicking completing the square, and we already completed the square to do this, right? So instead of setting this equal to 0 and using the quadratic formula, we could actually set that y to 0 here and have 0 equals x plus 7/2 squared minus the 65/4 and solve it here. Move over that 65/4, x plus 7/2 squared equals 65/4, square root both sides from there. X plus 7/2 equals the square root of 65 over 2 from the square root, plus or minus. And then subtract that over, -7. The halves are going to be the common denominator, so they'll combine, plus or minus the square root of 65 over 2. which is what this is going to simplify down into anyway, supposedly, right? It's the same 49 minus, it's going to turn into a negative 16. So the same 49 plus 16, it's the same 49 plus 16 that's right there. And it exists for the same reason, because again, this is mimicking completing the square. So once we have it in vertex form, setting it equal to 0 from there is a nice option. But, you know, when we're doing, especially when we're doing something like a test, this is going to feel more, you know, kind of secure. And that's perfectly fine. Just, you know, don't forget we have options. Oh, that lost a Stan.
Can we go over any trick questions you got on your test?
I don't have trick questions.
I
don't believe that.
I don't have questions that I think of as trick questions from my perspective. That's always the issue. It's like, you know, are all the questions fair? I think they're fair. Let's see.
If I email you the quiz scratch work after class, am I still good since there wasn't a link?
Oh yeah. Okay. And again, most of that was just to kind of work out bugs in doing that. So yeah, everybody can have, you know, just get it to me eventually and I'll work it out. Let's see. Oftentimes we'll see problems like, say the height of the projectile, right? You've seen a lot of those in your day, usually. So things like negative 16 x squared plus 40x plus 5. It's a projectile launched on Earth. We know it's on Earth because this is part of the acceleration of gravity on Earth. It is launched at a vertical speed of 40 feet per second and launched from an initial height of 5 feet. It's often interesting in a word problem with this, you are often told, you know, that it had an initial velocity of 40 and an initial height of 5, and you want to do something with that 40 and 5. But if you're given this equation, the 40 and 5 are already there. So there's nothing more to do with them. But some of the common questions here are things like, how long does this projectile take to reach its maximum height? And how long until this projectile hits the ground? So those are probably two of the more common questions. And as soon as it's in a word problem, it can kind of start throwing people off. So you've got a word problem, the equation such and such models the height of a projectile. How long does it take it to reach its max height? How long until it hits the ground? So again, I'll give you just a couple minutes to decide how you would start those. Ava, you were looking for more test-like stuff. Does this work for you? Is helpful stuff? Okay. Okay, just so we have some time before I have to let you guys go today. If we were to graph the parabola, it would certainly continue past these points, but it is starting at its y-intercept of 5. That's that starting height. It is starting upward from the positive 40, and it is accelerating downward with that negative, so it is opening downward. So we're asked to find how long it takes to reach this max height. So that's a when, so we're asked for this x value. And we're asked when it hits the ground. So how long did it take before it hits the ground? So we're essentially asked for this x-intercept. There's another x-intercept that we could technically find back here, but that isn't what we're asked, and technically isn't in the domain restriction of the problem for when the projectile is actually in motion. So we want the x value of that vertex, and we want this x-intercept. So one of the things I like about this question is I would approach this question fairly differently than this one, even though it's really the same question. Here we wanted to write vertex form. Here we want to find part of the vertex. Here we wanted to know, what its x-intercepts are. Here we still want to know what its x-intercepts are. But I'm not going to approach it either this way or this way, just because of the kind of nature of the problem. I want to know what the x value is where it reaches its max height, the x value of its vertex. I don't need this form like I did in this question. Technically, we don't even need to know the y value of the vertex, because we're not asked what that max height is. If we were, we could find it, but we're not actually even asked that. So I would here jump to the negative b over 2a, because that's going to give us exactly what we need. So that would be what, negative 40 over 2 times the negative 16. So 40 30 seconds, which is what, 5/4. So how long will it take to reach the max height? It will reach the max height in, if you want, 5/4 seconds, or 1 1/4 second, or 1.25 seconds, however form you want to answer that in. I would tend to say 5/4 seconds, but if you in the sentence and conversationally, people like things like 1.25. So we weren't asked what that max is, so no need to find the y value. We're just looking for that real quick 1.25. And you could spend a lot more time trying to find the answer than this. That's one of the goals that I want you guys to have, is kind of having your tools be flexible enough that you can really focus on getting just what you need out of the problem without spending a lot of your energy finding things you don't have to. Does that make sense? Now, if we were asked what that max height was, I'd probably still do it this way. We would just then take that 5/4 and plug it in for h. So if we're asked to actually find what the maximum height was, find h at 5/4. So you'd plug in the 5/4, crank that out, and you'd have what that max height was. So same idea, finding vertex over here versus finding vertex over here, but choosing a different methodology because our goals are slightly different. Finding when it hits the ground. It hits the ground when the height is equal to 0. That's why it's technically an x-intercept. So 0 equals negative 16 x squared plus 40x plus 5. We didn't complete the square in this, so I don't have the vertex form structure to solve very easily. This isn't factorable, or if it is factorable, it's ugly. And I don't even want to think about factoring that. I certainly don't want to complete the square on this. So Justin, just like you did with this problem, I would dump this into the quadratic formula and let that handle it. So what, negative 40 plus or minus the square root of 40 squared. So 1600 plus 4 times 16 times 5. It's a plus because that negative 16 is going to make it a positive. Over 2 times negative 16, so negative 32. And then simplify that down to whatever it simplifies to. Or heck, even just ask a computer or a calculator to crank that out for us. Because again, we're, a word problem here, we're probably going to give an answer rounded to a couple of decimals anyway, as opposed to an exact answer. So asking some shiny box what that is approximately I'm equal to is pretty reasonable. The one with the plus is likely going to give us this answer that we don't want. So I might just focus on the one with the subtraction. So negative 40 minus that divided by negative 32. That's going to give us our positive answer and probably the most interesting of the two. Anybody find an approximation for that?
Uh, 2.62.
2.62. And that seems reasonable. This is happening at 1 1/4 seconds. So this happening at 2.62 seconds seems reasonable. Again, you'd answer it in a sentence. It hit ground at 2.62 seconds. Write better sentences than I do. Even it will hit the ground. You and ground is sufficient.
Ball hit ground 2 seconds.
Yep. Ball hit ground, win, ouch. No, don't do that.
Or after ouch. Yep.
After ouch. Mm-hmm. After Matthew ouch, yes.
Mm-hmm.
So one of the reasons I kind of wanted to use both of these is I'm kind of approaching them differently, but because we're given the numbers in here are so much worse, so I don't want to mess around with this stuff. We're asked for answers in kind of different forms. So here the simplifying was fairly important because we wanted this nice exact value. Here, doing all this simplification, not as important because we want just an approximation. Here, we're not asked for it in a particular form. We just want to know what the numbers are. So just cranking out what those numbers are, trying to make sure with all the tools we have, we use the right tool the right way to answer what we're looking for specifically, without a lot of extra, work or extra time that's not necessary. Does that make sense? Questions about any of that before I let you guys go today? No. If there's anything else I can do for you guys today, let me know. I'll be around today. So send me a message, send me an email. I'll be checking those. If it's anything urgent, feel free to write urgent in the subject if you're panicking, and I'll try to get back to you as quick as I can. And if there's nothing else you guys need, have a wonderful day. Confidence. Be confident today. You guys are strong.